sealed classes, and interfaces. They both restrict which other classes or interfaces may extend or implement them. These features were introduced as a preview feature in Java 15 and were also available in Java 16 as a preview feature. But from Java 17, they have become a standard feature of the language, and now they are no longer a preview feature. So that means you can use them in your code with confidence that they are fully supported and will continue to be supported. Now, the question is, what's the primary purpose of inheritance? Of course, it is code reuse. When you want to create a new class and there is already a class that includes some of the code that you want, you can derive your new class from the existing class. By doing that, we can reuse the fields and methods of the existing class without having to write them by yourself. However, there are certain scenarios where reuse is not the only purpose of a class. There are scenarios where we want to model the various possibilities that exist in a domain by defining different entities and determining how those entities relate to each other. So, in other words, what if you want to control the inheritance hierarchy? What if you want to determine in advance that how your hierarchy is going to shape? Because in the case of a normal class, be it in Java or any other language, a class is always open for extension unless you explicitly mark or make it non extensible, restrict its inheritance or instantiation, like marking it as a final or by declaring its constructors as private and all that. But that's not the case all the time. Sometimes we want a class to be open for some and closed for others. When we want our class or interface to be open for extension for a specific set of classes, there comes the use of sealed classes or interfaces. It's about modeling various possibilities that exist in a domain. For example, here in this code, we have declared that my class shape, which is a sealed class, by because I put a sealed modifier before its name, will be allowed to be extended only by the circle, square, or rectangle. And same is the case with my interface, my sealed interface. So in that way, we ensure that how the inheritance hierarchy is going to take shape from onwards. To seal a class or an interface, we put a seal modifier before its declaration, and then we declare any other extension or implemented clauses if you have. And finally, we put the permits clause. This clause specifies the classes that may extend from your sealed class. Now the question is, if we are allowing a set of classes to extend from the sealed class, what are the constraints on those subclasses which we have permitted here? How they should behave and what are their limitations? So there are certain constraints on the permitted subclasses as well. Let's talk about those constraints. As per the official documentation of the Oracle, the permitted subclass have the following constraint. The first thing that we need to remember is they must have exactly one of the following modifiers to describe how it continues the sealing initiated by its superclass. So the subclasses of a sealed class can either be final, be sealed, or non sealed. When we say final, that means we are stopping the hierarchy there. Then the class cannot be extended further. When we declare it sealed, then it can do that, but then it will be again extended by its own permitted subclasses. And when we declare non sealed, that means the class can be extended by unknown subclasses. A sealed class cannot prevent its permitted subclass from doing this. So, what are the other constraints that are related to this? The first point is they must directly extend the sealed class. So there should be no indirect hierarchy here. They should directly extend the sealed class. They must be in the same module as the sealed class. And they must be accessible by the sealed class at compile time. For example, if here in this previous example, in the shape.java, the compiler must be able to access all the permitted classes of the shape. Circle.java, square.java, rectangle.java. And in addition, if other sealed classes are extending from your sealed class, then compiler needs to know or access their permitted classes as well. That's the main point. Another constraint that we need to remember is that they must be in the same module as the sealed class. If the sealed class is in a named module, if you have declared a named module for your sealed class, then they must be in the same module. Or if you have not declared a name module, then they must be in the same package. So either your classes should belong to the same module or to the same package, in whatever way you have decided to wrap them around. Now let's talk about the sealed interfaces. Like sealed classes, to seal an interface, we also add the sealed modifier to its declaration, as we have seen. Then after any extend clause, and then we add the permits clause, which specify the classes that can implement the sealed interface and the interfaces that can extend the sealed interface, like here. Now, what are the other special cases of the sealed classes? We have a special case for the record class. You can name a record class in the permits clause of a sealed class or interface. And record class, as we know, are implicitly final. So you need not to declare that class as either final, non-sealed, or sealed, because the record class is implicitly final. And finally, we need to remember that there are two methods that are given by the APIs related to sealed classes and interfaces. The first is permitted subclasses to get an array of all the permitted subclasses of the sealed class, and it will return an empty array if the class is not sealed. And another method is to check whether the class is a sealed class or not, that is sealed. That will return either true or false given if the given class or interface is sealed. So that's it. That's all for the sealed classes or sealed interface.